In this video, we're going to talk about what does it mean for a function to be continuous. F of x is continuous if the following three conditions are met. First, f of x must exist. The limit as x approaches some value a of f of x must exist. And the values that we get in step 1 and step 2 should be equal to each other. So for an example, it says find all points of discontinuity, if any. So this is a piecewise function. The first piece is a polynomial. In particular, it's a line. So I know this line is continuous everywhere. The second piece is also a polynomial. It's a quadratic, and I know it's continuous everywhere. The only place that we need to check is where they meet, which is at 3. So in this case, we're going to let a be 3. And we'll check it. So first thing we need to do is check whether f of a exists. So that means we want to see whether f of 3 exists. Well, we'll look at our piecewise function and we'll find the piece where x is equal to 3. And that's this first piece, the top piece. Because it says x is greater than or equal to 3. So there's the equal sign. So that piece is x plus 6. Replace the x with 3 and we receive 3 plus 6, which is 9. So f of 3 is 9. The second thing we're going to check is the limit as x is approaching 3 of f of x. Now this is a piecewise function, so we understand it should be in pieces. So let's first check the limit as x is approaching 3 from the left. If we look at our piecewise function, we determine that that should be the bottom piece because that's where x is less than 3. So that's x squared. And then the limit as x is approaching 3 from the right, and again f of x, well, we'll look at our piecewise function, and approaching 3 from the right is numbers greater than 3, so that is the top piece, x plus 6. Remember, we can evaluate our limits by using direct substitution. Remember, direct substitution plugs in the value for x, and in both cases we'll end up with 9. So already we can see that step 3 is satisfied because the values that we receive in step 1 and step 2 are equal to each other. So we can write it like this. The limit as x approaches 3 of f of x is equal to f of 3. Now remember, because we did the limit as x approaches 3 from the left and the limit as x approaches 3 from the right, and we get them to be the same value, that means the limit as x approaches 3 regardless from the left or the right of the function is equal to 9. So we can see that 9 is equal to 9. Therefore, this function f of x is continuous everywhere. If it was discontinuous, one of these 3 conditions would have failed. So as a recap, remember, if we're trying to determine continuity, we have to determine, first of all, does f of a exist? Does the limit as x approaches a of f of x exist? And third, are those two values equal to each other?